Hello, and welcome to Grafana, Loki, and MinIO. At the end of this training module, you will be able to use MinIO to store Loki data and investigate log files. What is Grafana Loki? Grafana Loki is a log aggregation system that is designed to store and query logs from applications and infrastructure. It's modeled after Prometheus, using time series data. It's multi-tenant, meaning that it's useful in large data center environments as well as single app or small environments. And Loki is frequently combined with Grafana and Prometheus to provide a holistic view and alert on metrics, logs, and traces within a single user interface. What are logs? We should know a little bit about logs before we dive into Loki. Logs provide basic system information and device information. It's very important to monitor logs, to watch them for errors, and issue alerts when significant errors occur or when thresholds are crossed for error rates, because logs are a valuable source of debugging and troubleshooting information. Logs are one of the tools that are at your disposal when tracking application health and crashes, and logs are frequently used to identify malicious activity and conduct forensic investigations about how people are navigating systems. And also, finally, logs can be used not just for troubleshooting or investigation, they can also be used to provide business intelligence and create strategies for business growth. Log storage is becoming quite the issue in the enterprise these days because logs are always growing. Indexing, searching, and storing them is resource intensive to begin with, so when there are more logs, it's more resource intensive. It's a big project to organize and store and search all enterprise logs. People frequently turn to public cloud infrastructure to provide this solution, but what we're going to show you today, how to use MinIO to store log data, and in doing so, you'll learn how to increase the performance and scale of your log analysis project. Now, what is Loki? Loki is software developed by Grafana. This Grafana, Loki, Promtail is roughly equivalent to the Elk stack, Elastic, Log Search, and Kibana, with the Promtail agent sending or tailing logs to the Loki data store, and then you visualize them in Grafana. Promtail is a logs collector. It uses the same discovery service as Prometheus, and it includes analogous and automatic features for labeling, transforming, and filtering logs before sending them to Loki. It's interesting to note that Loki does not index the full text of logs. Instead, it indexes the metadata, and entries are grouped into streams and then indexed with labels. You query them using logql. And you can also explore and visualize logs using the Grafana interface. And you can also configure alert rules and send alert to Alert Manager. Loki can be deployed locally to cloud platforms and to Kubernetes. What is the Promtail agent? It's an agent designed to acquire logs, turn them into data streams, and push those streams to Loki via the HTTP API. The Promtail agent supports just about everything you can think of in order to round up logs and send them to Grafana. BoltDB is also necessary for this tutorial. BoltDB is what enables Loki to store data and indices in object storage. BoltDB actually simplifies Loki deployment. It removes some potential points of failure and removes the cost of running an external database like Cassandra, Bigtable, or DynamoDB in order to build indices. You can build them and store them directly on MinIO. Loki is also about modernizing how we work with logs. Working with logs is a resource-intensive proposition, and enterprises go to great lengths to store logs and make them available, sometimes for a very long time, for analysis. But see, here's the thing. We spend all this time working on acquiring the log and storing the log, but the value is actually in what is in the log and how you can use that information, not in the log itself. And so logs must be thorough and they must be analyzed in order to actually understand what they're logging. And sometimes there's even a requirement to save them for regulatory compliance and auditing. MinIO happens to be a fantastic tool for storing logs. MinIO places no constraints on the number and organization of objects. MinIO distributes and protects the log objects with erasure coding across multiple nodes and drives. This is where you get the fantastic performance that MinIO is known for, as well as the resiliency provided by erasure coding. MinIO is also cloud native. It's API driven. And by storing logs on MinIO, you now open your logs to cloud-native application architectures and also to cloud-native analytics tools. Why would we want to save logs in object storage? Well, object storage is a pretty important technology because it allows enterprises to decouple storage from compute. They can now scale separate. This makes storing logs more efficient and also more flexible because object storage such as MinIO can be expanded as needed. There's also no need for separate data protection, like a separate cluster for snapshotting and replication. Object storage such as MinIO can protect the logs where they live. Object storage also provides an HTTP API that enables you to move to a cloud-native architecture. And this simplifies operations while expanding the ecosystem of available log management and analysis tools. People use MinIO to work with logs using Humio, Cribble, Splunk, Elastic, and now we're showing you Loki. And so again, MinIO abstracts away the storing of log data. It addresses data protection behind the scenes so you don't have to worry about it. MinIO exposes data via the ubiquitous S3 API, which means that you'll be able to use whatever cloud-native applications to work with your logs that you want. If you enjoy this tutorial, come back for the other one. And right before I sign off, I'll just remind you to join the MinIO Slack channel or shoot us an email at hello@min.io if you have additional questions.